If size n, find the majority element. The majority element is the element that appears more than n divided by 2 times. So the length of the array divided by 2. You may assume that the array is not empty and the majority element always exists in the array. So if we have 3, 2, and 3, the output's going to be 3 because 3 appears the most. And then if we have 2, 2, 1, 1, 1, 2, 2, the output's going to be 2 because 2 appears the most. So we can go about this a couple of ways. One is going to be the brute force implementation, which would just be like 2 for loops. We could have like an I and then have like a j, which could be I plus 1, and then maybe have some sort of like count variable. And so we can start it off at 0, and then as we go through we could say, okay, I matches j, so let's increment the count to 1 so we know there's at least one element that exists that matches our I. And then this doesn't match, so we'd skip. This doesn't match, so we'd skip. This doesn't match, so we'd skip. This does match, so we can skip. So we'd have 2, and then we'd move this forward, and then we'd say, okay, this does match also, so we'd have 3. So we'd probably want to actually keep track of our element, which is going to be 2, and then we can move I over. J starts over here again, and then our count becomes 0. And then we would basically keep repeating this process over and over again until we would find the answer. So we'll probably have to keep track of a current count, and then we'll probably have to keep track of a max count, and then whatever our max element is going to be. So the time complexity for this will be O of n squared, because we're repeatedly doing multiple loops, inner loops, and then the space should be constant because we only need to keep track of the variables. So if we implement this, all we would have is max element, which we could just set to the first element, and then we could also have our max count, which we could just set to 0, and then we know we're going to return whatever our max element is going to be. So now we can iterate. So I will be 0. I is less than nums.length, and then we'll create another count variable, which will start off at 0, and then iterate from j being I plus 1 until j is less than nums.length, and then we'll check if our current element matches nums of j, then we will increment our count, and then afterwards we'll just check if our count is greater than our max count. Then all we have to do is reset our max count to our current count, and then our max element to nums of I. And so this is kind of just doing what I briefly went over earlier. So if we run it, and then if we submit, this will pass, but we're not doing the best on the runtime, but we're doing really good on the memory. So how could we do better as far as the runtime? Another way is to sort it. So given this array, if we were to sort it, we would just have it be 1, 1, 1, and then 2, 2, 2, 2. Now looking at the problem description, we can kind of cheat since we know that the majority element is the element that appears more than n over 2 times. Well, what's the middle point of this array? 2, right? And we know that 2 is going to be the most frequent element. So we could just return whatever our midpoint is going to be. It's the exact same thing for the first example also. So this is example 2. If we do example 1, then, and we're given 3, 2, 3. If we sort it, then we know we're going to have 2, 3, 3. And then what's our midpoint again? The most frequent element. So The worst case runtime we have to worry about is just sorting. So the time complexity will be O of n log n for sorting, and then space complexity will be O of n. And so if we do that, all we have to do is sort nums. So this is just going to do comparison sorting, which will sort it numerically, and then grab whatever our mid index is going to be, which would be now all we have to do is return nums of whatever that mid index is going to be. So we can run it and then submit. Cool. So we're doing better on the runtime, but not so hot on the memory usage. So can we do better as far as our runtime? I think we can. So we can just use a frequency or a hash table, which will literally just count how many times we've gone through. So starting off at index, the first index, or 0, 0, 1, 2. So this would be the index, and then this would be the elements. And now, once we start off at index 0, we can check, okay, we've seen 2 once, so we can move our index over, and then, okay, now we say we've seen 2 twice, and then move our index over, and we say, all right, we've seen 1 once. And then we can move our index over, and then we can say, okay, we've seen 1 twice, so we can move our index over. And now we could say we've seen 1 3 times. Now we can say, all right, we've seen 2 3 times, and then we've seen 2 4 times. So now all we have to do is just iterate over this array. We could probably just grab the mid again, and then say whichever element appears more than the mid is going to be our result. So the time complexity will be O of n, and the space will also be O of n. So we can implement that by having a frequency table. Just going to use reduce, and we'll reduce our elements into an object, and we'll say our current. Our frequency of our current element is going to be either accumulator current or 0, and then we can increment by 1, and we'll return whatever that accumulator is. Now we can just iterate for our key in our frequency. We can grab the mid again, and then we'll check if our frequency of mid matches frequency of mid. If our key, frequency's key, matches mid, then all we have to do is return whatever that key is going to be. And so we can run it. Let's try mid minus 1. Mid minus 1 frequency. Hold on. If our key, we need the length of the array. Let's see if it matches the mid. Undefined. Nice. Exactly what we wanted. So hold on. We need to check if our frequency key at least shows up the mid amount of times, then let's see what mid is. And then what our frequency key is going to be. So mid is 1, frequency key is 1. Interesting. What is our frequency table? Look like 2 appears once, 3 appears twice, and our mid. Okay, so let's see if it's mid plus 1. Yeah. Get rid of these console logs. Slightly off. And we can submit it. And define. Nice. Bombing this last part. Frequency is equal to, let's see if it's greater than or equal to our mid plus 1. Yeah. Very cool. So yeah, those are going to be our 3 approaches, and that's how we can approach this problem. Like, comment, subscribe, and I'll see you in the next video.